All right, so we're going to go over this quiz here. This is a quiz correction, June 2021. Okay, so circle the letter that best represents or best corresponds and show work to earn partial marks. So everything is worth 2, but if you show me some work, even if you get it wrong, you might still score a mark or half or 1.5, we'll see. So in a standard aptitude test, with a mean, right, the mean is 650, the standard deviation is 15.3. What is the z-score of a mark of 678? So if you watch the video on this particular, I made a lesson where I show you how to calculate it by hand. And in this case, you're not given, you're not asked for percentage below or above or between. So normal CDF isn't going to help you here. Inverse norm isn't going to help you either because you need the percentages to the left of it. There are creative ways of using a combination of normal CDF and inverse norm, but I would just say if it's asking this, just use your formula z-score. It's x minus x bar over standard deviation, which is the score actually here is 678 minus the mean, which is 650 over 15.3, and that is if you go 678 minus 650, that's 28 over 15.3, and that is 1.83. That's the z-score. Okay, and so if you made a small mistake here, you picked the wrong one, you can still get partial marks here. So if you flip this, for example, you would have gotten a negative, still get 1 out of 2. So you can skip forward to the one you need the most, right? Or you struggled with the most. In a normal distribution, find the percent of data between Z and Z. So these are z-scores, right? So basically, if they ask you that, we want to go normal CDF. And we're going to go from negative 0.5 to 1.63. And because we're talking z-scores, our mean is 0 and our standard deviation is 1. So we type that in. Second vars, normal CDF, and it's negative 0.5, 1.63, 0, and 1. And we multiply that by 100. And so it's 6.40% rounded, right? Because the 9 bumps that to a 10 there. So we have that. And let's continue. So 6.40. Oh, wait, did I make a mistake here? Let me just check that. And yes, I can see it on my screen here clearly. I just multiplied by 10 instead of 100. So it's 63.99, right? 63.99%. My bad. It's all about catching your mistake, right? So A is the answer there. And then question 3, a car tire has a mean life of 64,000 with a standard deviation of 3,200 and a purchase of 1,500 tires. The number lasting less than 57,600 kilometers would be, right? So here you have to imagine your normal curve, right? It's best to use it, right? You know that the average lifetime for tires 64,000, a standard deviation of 3,200, but cars lasting less than 57, so we know that's going to be somewhere here, right? So we need to find the percentage first, and then we can calculate the actual number of tires that would represent, right? So first we use normal CDF, and we want anything less than this, right? So negative 10,000, and it's 57,600. The average is 64,000, and the standard deviation is 3,200. So we're going to come up with that first. Okay, so we're going to go second vars. normal CDF, negative 10,000. We're going to go 57,600, comma 64,000, comma 3,200. Close that. You get that. So we're going to write that down, 0.022, and that keeps going. I'm just going to leave that on my calculator, and then I will say tires would be 1,500 tires times 0.0227. You can use all decimals there. So it's 1,500 times the percentage of tires that would apply, and that's 34.12, which is approximately, you can go 34 or 35 tires. I changed that to 34, but I make this key before you're writing it, so it's supposed to be 34 there. The reason why I had a 38 at first is because if you can actually graph this normal curve and actually get to an exact value, which is 57,600, and then it would be slightly off, but 34 is what I'm after here. Okay, question 4. Bart wrote a test and achieved a z-score of 2.25. The test scores were normally distributed with a mean of 64.9 and a standard deviation of 5.6. What is the actual score of the test? So because you're given the mean and standard deviation as well as the z-score, you can use this formula, right? Standard deviation times z-score plus the average will give you that. So standard deviation is 5.6, z-score is 2.25, and the average is 64.9, right? And that gives you 5.6 times 2.25 plus 64.9, and that's 77.5, right? Is the actual mark. So C is your correct answer there. A company gives its prospective employees a basic skills test. Generally, the company hires its staff from the top 8%, that's key percentage, right, of its applicants. Assuming the test scores are normally distributed, that's always our assumption in almost every single question here. When we are using normal CDF, inverse norm, any of these, you have to assume that. What would the minimum z-score that the applicant could earn be considered for employment? So again, I want you to imagine the normal curve, okay? Normal distribution, and the top 8% would mean, right? If you have to agree that the top 8%, we're talking about the 8% at the top here of in terms of performance, right? This is always your top and this is the bottom, right? So top 8% would be here. That means that 92% of data would be below this cutoff here. In this case, we're not interested in the actual score. We're interested in the Z value. Remember, you can have standard deviations here, the actual value, which would be probably percentage on that test, right? But we want the Z-score. So how do we do this? Well, we know the percentage to the left of it, and because we're talking z-score, we know that x is equal, x bar is 0 and standard deviation is 1, right? If we're talking z-score. So here we use inverse norm. We want 0.92, and then we want 0.1, like that. Because that is going to give us our z-score, because when this is true and this is true, we are getting a z-score. Okay, so we're going to go, could you have calculated it by hand? Sorry, some of you are probably like, how could you don't know the average and you don't know the standard deviation. So it can't do it, right? So second vars, inverse norm, 0.9201, and it's 1.41 rounded. That's the z-score. So students that have a z-score of 1.41 and higher, right? This is the z-score is 1.41. We don't know what the average is if you were to look at the actual data, like what mark you would need to have. We don't know that, but we do know that the z-score would have to be 1.41, okay, and higher. So there you go. That's the first page for you. Short answer: the flight between Vancouver and Winnipeg has a mean of 156 minutes, standard deviation of 3.5. Assuming that the flight times for this trip are normally distributed, right? Graph the normal distribution, including plus or minus for standard deviations. Label everything. So I'm going to pause here. I'm just going to graph it, and then I'll show you the end result. And there's the curve. So I'm looking for the correct values down here. I'm looking for a label here, flight time in minutes, the percentages, and obviously the bell curve, right, in that shape. It would not want you to be touching the x-axis there. And the reason why we don't touch is because technically it is possible that there's a value way down here and way down here, even though it's very unlikely. But it is possible, right? Those will be outliers. Okay, so determine approximately what percent of the time you could expect the flight time to be less than 152.5. So that is actually on the curve because I made you graph it, right? So it's just 13.5 plus 2.35 plus 0.15%. Okay, so that is 15, it's 2.5, 14, 16%, sorry. 16%, there it is. 149, right, and 159.5. So you have 34 plus 34 plus 13.5. That's 68 plus 13.5. And that is 81.5%. So we have that there. And longer than 149 minutes. So 149 longer. I'm going to go the indirect way. I'm going to go 100% minus 2.35% minus 0.15%. Because if I take away this here, I have the flights that take longer percentage-wise, right? So it's basically 100 minus 2.5, right? So that is 97.5% of the time flights will take longer. So I could ask you, like, if there were like 200 flights in a week, how many of them would you expect to take longer than 149? You take this and multiply it by the number of flights, okay? Okay, next, during a fitness awareness week, the number of sit-ups completed by participants was collected. Calculate the mean and standard deviation given the table to the right. So here you need to find the midpoints, okay, of the sit-ups. So I told you, if you're not sure what to do there, 36 plus 40 divided by 2, that gives you the midpoint. So that's 38, right? And it's 41 plus 45 equals, divided by 2, that's 43. And then you can see that it's going to be, it has to be consistent, right? The interval width is the same. So you see that you've gone up by 5. So just go up by 5 every time. 48, and then it's 53, 58, 63, 68, 73, 78, 83, 88. Okay, so then you have, sorry, it's a little crooked there, but these are the midpoints. So this goes into L1 and the frequency goes into L2. So that's part of the work that I would expect you to do, right? So we go one variable stats, L1, comma L2, and the mean and standard deviation we're going to find, okay? So we're going to go stat edit, clear whatever I have there. I'm just making sure 11, so 2, 4, 6, 8, 10, 11. There's 11 entries, so we're good. And then we type in the frequency. Oops, I put in 22 there. That would be way off. And so now we got to go stat, calculate one variable stats. You got to use the L1 and L2 method. And so we notice that there's 129 participants, but we write down our average, which is 62.81 sit-ups, right? You just write it as a decimal, that's fine, and it's 10.16. Okay. If you do round it, that's fine. Sorry, that would be the average number of sit-ups, right? Okay, so we have that. I don't know if you wanted to do a quick check, right? 1 and 9 is 10, 15, 15 and 15 is 30. 30 and 23 would be 53. We have 59, 69, plus 2 is 71, 91, plus 4 is 95, 105, 113, plus 6, 119, that is. I must have missed one number there. Let me check that quick. And never mind, I did it again, right? 15 here, 15 there, 49, 36, and 14. If I add up these values, I do get 129. So I just made sure that that adds up. So I have that graph, a histogram. Histogram is just a bar graph, right? So again, I will pause it and then you can fast forward if you want. So I decided to record it after all. So zipper here for sure, because you're not starting even close to 0. So you go 36, right? And then we're going to go to 40. And I know this is different here, right? We go 41, but we're just going to go 40 and then to 45 and then 50 and so forth. So 36 to 40, and then it's 45, 50, 55, 60, 65, 70. Got to keep the spacing about the same. 75, 80, 85, 90. And so this is sit-ups, right? Number of sit-ups. And here you have your frequency. And I need to account for a high number of 26. So I'm going to go 10, 20, 30. No zipper there, right? Because I'm starting from 0. And you can split that up into halves, right? Just to make it a little easier. So 36 to 40, you have 1. So it's going to make this bar nice, shallow, right? And then it's 5 for the next category. And then it's 9 for the next category. Should be using a ruler. 15 for the next one. By the time you see it, I will have changed these numbers to 36 to 40, 40 to 45, and so forth. Or maybe I'll leave them. I'll see. 15, 23. I still have to label the bottom. I know that. 23, and then you have 26. So it'd be 55, 60, 65, 70, 75, 80, 85, 90, right? 26, so this goes past the 26, and then we've got 22. Should be a little shorter than the 23 bar. 14, should be a little shorter than the 15 bar, and then you've 8 and 4 and 2. Okay, so there's your histogram, everything labeled, zipper there, and so you got that there. Okay, next, question 3. We have a candy company sells boxes of chocolates, and if the weights of the chocolates follow normal distribution with a mean of 350, standard deviation of 7, what's the percentage of boxes that weigh at least 336? Percentage they're asking, so normal CDF, at least this much, right? So 336.5 to 10,000, and your average in here is 350 and 7, because we're not asking for we're not given Z scores, right? We're given actual values. So we're going to figure that out. Normal CDF, 336.5, 1,000, 350, and 7. That gives you 0.9731. Keep going, multiply that by 100, and you get 9731. Rounded to 2 decimals. Okay. If a company produces 20,000 boxes per day, how many would weigh at least 336? So we're talking about the same weight, so I can use this value up here. So boxes would be 20,000 multiplied by 0.9731. We can use all decimals, so it's 20,000 times, I'm going to go times, go back up and get that number, and then hit enter, and that is 19,462.16, which is approximately 19,462 boxes. Okay, you've got that. Next, last Friday, an applied class wrote a math test, was worth 56 marks. The average score was 32, standard deviation was 6. Find a percent of students scoring less than 23 marks. Normal CDF, less than 23, so it's negative 10,000 up to 23, and the average is 32, and it's 6 there. So we're going to go second vars, normal CDF, negative 10,000, 23, 32, and 6 at 0.0668, and it keeps going. Times it by 100, you get 6.68% of students scored less than that. Between 25 and 40 marks, this actually gives you both limits, 25 and 40, and this is 32 and 6. And you have 0.7871 that keeps going, multiplying that by 100, you get 78.71% of students would be between those marks. Greater than 45, again, normal CDF, 45 is the lowest, 10,000 is the greatest, or that's for us the greatest, even though it's just a big number to represent, far to the right, so you include everything to the right of 45, and still my average is this. So we're going to go and call normal CDF, 45, 10,000, 32, and 6, 0.0151, that keeps going, multiply that by 100, we get 1.51% scored more than 45. Okay, and then we have if only 10% of all students got a greater score on the math than you, so only 10% greater, that means that we're to the right of you, what is your score? Show what you're punching in and as well as your answer. So here you're given percentage, right? So let's do this here. Normal distribution, right? Now we're interested in the score. And if 10% got greater, you know, like this would be 50, right? Where 50 are below you, 50 are above you. 90 is right here, right? 10% is right here. You want the 90, right? This is what you're interested in because inverse norm needs what's to the left. So this is greater. You want this percentage that is below you. So inverse norm, you'd have to go 0.90, and the average is 32, standard deviation is 6. So that will now give us this x value that we're after. Okay? So second vars, inverse norm, 0.9, 32, and 6. And that's 39.69, which is approximately 40 marks. Okay? So that's how you do that. That's why it's 2 marks, because this here is worth 1 mark because you have to actually think about what goes in here. It's not just a 0.1. If you put in 0.1, then you're actually finding the score you would get here because there's 10% to the left of you there. Okay. Russell achieved a mark of 27 on his test. Calculate his z-score. So how would you do that? How would you calculate the z-score? Well, in this case, you can use the formula, actually using the formula, which is the z-score is the mark minus the average divided by the standard deviation. You have all of these things, right? So the mark is 27, the average is 32, the standard deviation is, I gotta go up and check again, 6, okay? So here you have -5 over 6, and so we're gonna figure that out. That is negative 0.83 is the z-score. So you are below the average, right? And which is clearly visible anyways. So a mark of 27 coincides with a z-score of negative 0.83. So you're not quite a full standard deviation to the left of the mean. Okay. And last question here before we continue, or before we're done, I guess. And you're about to write this quiz, so I gotta hurry. The height of the adult females in Canada is normally distributed with a mean of 164 and a standard deviation of 4.10. Prior to 1985, the Winnipeg Police Service considered the height of 157 or less to be too short for women to join the service. What percentage? So they're asking for percentage of adult women would have been too short to join the police service. Indicate your strategy. So here you want to use normal CDF because they're asking you for the percentage, right? And we are going to find out, we're going to say, hey, I want to find out the percentage of women that are less than 157, right? So there's a lower limit of negative 10,000 and the average is 164 with a standard deviation of 4.10. Okay, so we're going to figure that out. Second vars, normal CDF, negative 10,000, 157, 164, 4.1. And that's 0.04388. It keeps going. Multiply that by 100. You get 4.39% if you round it correctly. So 4.39 of women would be too short for in this case. Okay, given what we know about, Canada's average and the standard deviation. Okay. Then we have before 1985, 12.4% of adult females were too short, meaning, right, this percentage was too short, meaning that they're telling us the percentage to the left to enlist the Brandon Police Service. What minimum height was being used in Brandon for the selection process? So obviously, if 4.39 of women were too short in Winnipeg, Brandon must have used a higher, right? Their minimum height must have been higher. Okay, so we're gonna find out. We inverse norm because we want actual value, right? We know that this is 0.124. Okay, 12.4% is that. The average is 164, and the standard deviation is 4.1. So we're going to figure that out. Second vars, inverse norm, 0.124, 164, 4.1. So that is 159.26. And this is actual value, so this is centimeters, was used by Brandon Police. Okay. And then last but not least, if Winnipeg had 980 women enlist, how many would have been considered too short? You already know the percentage that would have been too short. So it's too short would have been 0.04388, keeps going, right? Multiplied by 980 women. So we're going to go ahead and we'll copy that value and go times 980, 43.003, right? So approximately 43 women. Okay, that's it. Hopefully this helped, and study for the test, okay?